So finally, we're at our summary and review for annuities and mortgages. So first off, we covered annuities. An annuity is a series of equal payments made at regular intervals. And we looked at two types of annuities, present value and future value. Recall that present value means we start with a sum of money, and after each regular payment, we reduce that sum of money until we get down to zero. The present value of an annuity is the principal that must be invested today to provide regular payments of an annuity. For example, making monthly withdrawals or payments of $1,000 for the next 10 years. Whereas if we talk about future value, you start with zero, and then we add money to an account at regular intervals until we reach our final amount. So the amount of annuity is the sum of all the regular deposits plus interest. For example, making monthly contributions of $1,000 into an account for 10 years. So our present value formula is shown here. This will help us determine the starting value of a loan given a regular payment. And this is the amount or future value. This formula will help us determine our future value or final amount when we make regular deposits that include interest. Next up is our second formula. It's just a rearrangement of our present value formula. Example when we would use this formula is when we're making monthly payments for a $10,000 loan for the next 10 years. This will help us find the regular payment. Here's our future value formula to determine the regular payment. So for example, making monthly contributions into an account so you can have $10,000 in 10 years. This formula will tell you how much you need to put away every month. So recall that PV represents the present value of an annuity, A represents the future value, R represents your regular payment, how much you pay or how much you put into an account, I represents the interest rate, but remember we always have to convert that to the correct compounding period, and N represents the number of compounding periods, how many times you make your deposit or how many times you make your payment. If you're looking to find the interest earned on an annuity, it's the difference between the total of the regular payments and the amount or present value of the annuity. So depending which type of calculation you're doing, it's either going to be subtracting from the amount or subtracting the present value. So let's go through some examples. So Matthew deposits $45 at the end of each week. So right away we know we have our R, our regular payment. So we're either looking for the present value or the future value. Second key is, it says that Matthew deposits $45 at the end of each week. So that means he's putting money into an account. So therefore, we're most likely looking for the future value. So that means we're going to use the following formula. A equals R 1 plus I to the N minus 1 over I. We know our variables R, I, and N. So recall that our regular payment shown here is $45. Our interest rate is 2.34, so 0.0234. And since it's compounded weekly, we're going to divide by 52. And that gives me 0.00045 as my weekly interest rate. And finally, N, the number of compounding periods, is 35 times 52. 35 years, 52 weeks each year, which means we have 820 weeks in 35 years. So next, let's sub in our variables. Which gives us $126,781.27. And part B, calculate the interest earned for his investment. Well, we know the total of the investment is $126,781.27. He deposited $35 1,820 times, which gives us $63,700. And if we subtract, he earned $63,081.21. Example 2. Katelyn finds a loan for $230,000. So notice we're looking at a loan, so that means we're going to be trying to make a present value calculation, one of the two formulas. And notice we're actually given the value of the loan, so that is the present value. And the second key thing is we're looking for a monthly payment. So always look at what it is you need to use. So if I'm looking for a monthly payment, I need the formula for the regular payment, R. And since this is a loan, we're going to use our present value formula, so PV times I over 1 minus 1 plus I to the negative n. So for this one, we need our present value, we need our interest rate, and we need the number of compounding periods. So the amount of our loan is $230,000. The interest rate is 0.0576, and we want to convert it to monthly. And this gives us 0.0048. That is our monthly rate. And at 30 years times 12, this tells us there are 360 payments to be made. All right, so let's put in our numbers. So we have 230,000 times 0.0048 divided by 1 minus 1 plus 0.0048 to the exponent of negative 360 and close that bracket. Next, use your calculator, which tells us his monthly payment will be $1,343.68. So next part, calculate the interest earned. Since this is a loan, we start with the payments. So Katelyn made payments of $1,343.68, and he made 360 of them. He ended up paying $483,724.80. Let's subtract how much he borrowed. So he borrowed $230,000. So he ended up paying $253,724.80 in interest. All right, example 3. Suppose you make regular quarterly deposits to amount to $3,000 over 5 years at 9.36% per year compounded quarterly. What is the quarterly payment? So first of all, we see we're looking for a payment, so we need a formula for R. And we're making deposits, and we want to reach an amount. So keyword here is amount. So what is the quarterly payment? That means we need a formula for R. And since we're looking for a future value, since we're looking for the amount, that's going to be A times I over 1 plus I to the n minus 1. Let's state our variables. So we need A, I, and n. So our final amount is $3,000. We're going to invest at 9.36%. Compounded quarterly, so we need to divide by 4. And similarly, we're doing this for 5 years, so we're going to times it by 4 to get how many quarterly payments we need to make. Same as the last ones, let's sub in our variables. So our final amount is $3,000. Our interest rate is 0.0234, and this is over 1 plus 0.234 to the exponent of 20 minus 1. So we end up having a regular deposit of $119.34 every 3 months. So how much money will you make? Well, remember, your total is $3,000 at the end, but you made 20 payments of $119.34, which means you deposited $2,386.80, and after 5 years, you made an extra $613.20 in interest. All right, last one before we look at mortgages. So Jessica purchased a new computer. So first of all, you're purchasing something. So that means you're going to take a loan, most likely. So this should be a present value type calculation. She's going to make bi-weekly payments. Another hint, you're going to pay off this loan of $40 for the next 2 years. And she's charged 18.72% per year compounded bi-weekly. What was the original value of Jessica's computer? What we're looking for is what's called the present value. So we have PV equals R 1 minus 1 plus I to the negative n all over I. Same as the last few examples, we need the variables that are on the right side. So we need R, I, and n. So we know that our regular payment is $40. We know that our interest rate is 0.1872. And since that's bi-weekly every other week, so remember in a year, there's 52 weeks. So we're going to divide this by 26, which means we're going to take the 2 years and times it by 26. So we're going to make 52 payments of $40. And our interest rate is 0.0072 every other week. So let's sub in our values. So we have 40, 1 minus 1 plus 0.0072 to the exponent negative 52 all over 0.0072. Using our calculator, we get the value of the computer was $1,729.86. So how much more did Jessica pay for her computer by using this payment plan? Well, let's calculate that. So Jessica made 52 payments of $40, which means she paid $2,080 for the loan, and the computer's value was $1,729.86, which means she paid an extra $350.14 for this computer. And the second big topic of this unit was mortgages. So remember, a mortgage is a loan that is used to buy property. In Canada, interest rates on mortgages can be compounded at most semi-annually. However, mortgage payments are usually made monthly or bi-weekly and so on. Since the payment period and the compounding period are different, we need to use the following formula to find what's called the equivalent interest rate. So where I equals that equivalent interest rate, S represents the semi-annual rate, which you'll usually see, and K represents the actual compounding period. So if this happens to be monthly, then this K value will have to equal 12. If it's bi-weekly, like the example above, then the K value would be 26, and so on. So let's go through one example on how to find the regular payments for a mortgage. So example 5, given a mortgage of $250,000 paid over 25 years at 4% per year compounded semi-annually. Step 1, show that the equivalent interest rate is equal to 3.9671, and then determine the monthly payment. So let's start with the equivalent interest rate. So I equals K 1 plus S over 2 to to the exponent of 2 divided by k minus 1. So for this one, we know that our k, since we want monthly, is 12, and our semi-annual rate is given above to be 0.04. So let's sub those into our formula. And notice when we do that, we get approximately 0.0396706. So that's rounded up to 1. So now we see that this equals this. So we've done part A. We've now got our equivalent interest rate. Part B is to find the monthly payment. So since this is a present value calculation, since we're taking a loan, we need the following formula. R equals PV times I over 1 minus 1 plus I to the negative n. And we have our values. We know the present value of this mortgage is $250,000. The interest rate we just calculated to be 0.039671, but since we want a monthly value, we're going to divide it by 12, and that gives us 0.0033059. And finally, the n. So we're making monthly payments for 25 years, so 25 times 12 is equal to 300. Subbing all this into our formula, we get R is equal to 250,000 bracket 0.00333059 over 1 minus 1 plus 0.00333059 to the exponent of negative 300. All right, last step. Let's use our calculator. And I end up seeing we have a mortgage payment of $1,315.05 every month. So here are some practice questions that you can try before the assignment. And good luck.